Here we have x raised to y is equal to e raised to x minus y, and we have to find dy by dx. Now our first step, take log on both sides. So here we'll get log x raised to y is equal to log e raised to x minus y. Let's simplify our equation using third property. According to our property, we can say this y, which is in power of x, can be moved to the multiplication of log. Similarly, on right hand side, this x minus y will move to the multiplication of log. So we can say y into log x will be equal to x minus y. The value of log is simply 1. So here we get our simplest form of equation. We want dy by dx in purely function of x. So we have to make y subjective. So let's collect all the terms of y on the left side, and for that we have to take this y on the left side. So we will get y log x plus y is equal to x. Now we can say y is equal to x upon 1 plus log x. So now let's differentiate our equation with respect to x. So on left side we will get dy by dx, and on right side we have to apply division rule. And according to division rule, your 1 plus log x will be as it is. We have to differentiate our x, which is 1, minus x will be as it is. We have to differentiate 1 plus log x, and it is 0 plus 1 by x upon 1 plus log x the whole square. So this x cancel out. In numerator we will get 1 plus log x minus 1. To simplify our denominator and to get answer which is given within the option, we have to change this 1 by log e. This log x will be as it is. So here 1 will cancel out, and in numerator only remaining term is log x. Upon using first property of log, we can say our denominator can be simplified as log e into x the whole square. We get our dy by dx is equal to log x upon log ex the whole square, which is given in option A. Ta-da! Here we have y raised to x is equal to 2 raised to x, and we have to find dy by dx. First of all, let's take log both the side. So log y raised to x is equal to log 2 raised to x. Now let's use third property of log to simplify our equation. We can take this x on the multiplication of log. Similarly, on right side, x will go with the multiplication of x. So we are ready to differentiate our equation with respect to x. So on left side we have to apply multiplication rule. So x will be as it is. Differentiation of log y will be 1 upon y dy by dx, plus log y will be as it is. Differentiation of x will be 1. On right hand side, differentiation of x will be 1, and we don't have to worry about log 2 because it's a purely constant term. Now let's make dy by dx subjective. So here we'll get x by y dy by dx, and rest of the terms should be collect on right hand side. So let's move this term on the right hand side. So log 2 will be as it is minus log y. So we can say your dy by dx is simply y upon x and log 2 minus log y. Using the second property of log, we will get log 2 upon y. Ta-da! This is your final answer, which is given in option A. Here we have y is equal to x raised to x, and we have to find dy by dx. Now our first step is take log both the side. So on left side we'll get log y, and on right hand side we will get log x raised to x. Using third property, we can say this x will go in multiplication of x. Now we are ready to differentiate our equation with respect to x. So differentiation of log y will be 1 upon y dy by dx, and on right hand side we have to apply multiplication rule. Let's say x will be as it is. Differentiation of log x is simply 1 by x plus log x will be as it is. We have to differentiate our second term, which is x. So differentiation of x will be 1. So this x will cancel out and we will get dy by dx is equal to y into 1 plus log x. But to get the answer which is given in the question, we have to substitute the value of y, which is x raised to x, and we can replace our 1 as a log e plus your log x will be as it is. Let's use first property to simplify our bracket. Your x raised to x will be as it is, and log e plus log x will become log ex, which is given in option A. So it is your final answer. Ta-da! Here we have x raised to y into y raised to x is equal to 100, and we have to find dy by dx. Now let's take log on both the sides. So we'll get log of x raised to y into y raised to x is equal to log 100. Now on left hand side, let's split this term using first property. We will get log x raised to y plus log of y raised to x is equal to log 100. Now for further simplification, you have to use third property, and according to third property, we can say your y will go within the multiplication of log, and similarly in second term, x will go to the multiplication of log. So here we get our simplest equation. So we are ready to differentiate our equation with respect to x. So to differentiate first term, we have to apply multiplication rule. Let's say in first term your y will be as it is. We just have to differentiate log x, which is 1 upon x, plus your log x will be as it is. Let's differentiate y. We will give us dy by dx, plus let's move to the differentiation of second term. Again we have to apply multiplication rule. So x will be as it is. We have to differentiate log y, which is 1 upon y dy by dx, plus log y will be as it is. We just have to differentiate x, which will become 1, is equal to differentiation of 100, which is purely constant term, will be 0. Now collect all the terms of dy by dx on the one side. From second and third term, we can take dy by dx common. So rest of the terms are log x plus x by y, and rest of the two terms should be moved to the right hand side. So we will get minus y by x plus log y. So finally your dy by dx, after taking LCM, we will get y by x. In numerator we will get y plus x log y upon y log x plus x, which is given in A option, which is your final answer. Ta-da! If y is equal to x plus 1, x plus 2, x plus 3, x plus 4, x plus 5, then we have to find dy by dx at x is equal to 0. Now we should take log on both the sides. So we'll get log y is equal to log of all the terms. So On right hand side we have log a into b into c into d into e, right? So let's apply first property to simplify the right hand side. So we will get log a, or we can say log x plus 1, plus log b, which is log x plus 2, plus log c, which is log x plus 3, plus log d and e. So here we get the simplest form. Now let's differentiate our equation with respect to x. So differentiation of log y will be 1 upon y dy by dx. Differentiation of log x plus 1 will be 1 upon x plus 1 into differentiation of x plus 1, which is 1, plus differentiation of log x plus 2 will be similar way, 1 upon x plus 2 into 1, plus differentiation of log x plus 3 will be 1 upon x plus 3 into 1, and same way the differentiation of rest of the two terms. So here we get dy by dx is equal to y into all the terms, but we need to find dy by dx at x is equal to 0, and for that we also going to need the value of y at x equal to 0. So let's put x is equal to 0 in first equation. So we get y is equal to 0 plus 1, 0 plus 2, 0 plus 3, 0 plus 4, and 0 plus 5. Here we get y is equal to 120. So at x is equal to 0, your dy by dx will be y, which we already find out as a 120, then upon x plus 1, or we can say 0 plus 1, plus 120 upon 0 plus 2, plus 120 upon 0 plus 3, and so on. In further simplification, we will get 120 plus 60 plus 40 plus 30 plus 24 is equal to 274 is your final answer, which is given in option D. Ta-da! If y is equal to log x raised to x, then we have to find out dy by dx. Here, as you can see, we already have log x raised to x, and without taking any extra log, we can apply third property to move this x to the multiplication. Now simply just differentiate our equation with respect to x. So we'll get dy by dx. On right hand side, we have to apply multiplication rule. So your x will be as it is. We have to differentiate log x, which is 1 by x, plus your log x will be as it is. We have to differentiate x, which will be 1. So here we'll get 1 plus log x, which is not in the option, but if we replace our 1 by log e, then we will get log e plus log x, which can be converted using first property as log ex, which is given in option B. So B is your final answer. Ta-da! Here we have y is equal to x square plus x raised to log x, and we have to find dy by dx. Your y is combination of two terms, x square and x raised to log x. So to differentiate second term, we have to apply logarithmic differentiation. So here we have to differentiate these two terms one by one. Consider first term as a u and second term as a v. So let's try to get differentiation of v, which is your x raised to log x. So let's take log on both sides. So on left hand side we will get log v, and on right hand side we will get log of x raised to log x. For further simplification, we can say this log x will go within the multiplication of log x. So finally, here we'll get log v is equal to log x the whole square. So if we differentiate our equation with respect to x, we will get differentiation of log v, which is 1 upon v dv by dx, is equal to, on right hand side we have to apply chain rule. We have to consider box around the log x. So differentiation of box square will be 2 times box into d by dx of your box. Within the box we have log x. So we just have to multiply differentiation of log x, which is 1 by x. So we can say your dv by dx is simply v into 2 log x upon x, or if we substitute the value of v, we will get x raised to log x into 2 times log x by x. Done? Now let's try to get differentiation of u, which is your x square, and its differentiation is simply differentiation of x square, which is 2x. So let's get back to our original question where y is equal to u plus v. So we can say your dy by dx is simply du by dx plus dv by dx, where du by dx is simply 2x plus your dv by dx is simply x raised to log x into 2 times log x by x. Now to get our answer, we have to take the LCM of x. So here we'll get 2x square plus x raised to log x into 2 times log x whole divided by x. After taking 2 common, you will get 2 times x square plus x log x into log x upon x, which is given in option C. Ta-da! If y is equal to 1 plus 1 by x whole raised to x, then we have to take dy by dx. Now, this is first form of logarithmic differentiation. We already have our y. Now let's take log on both sides. So on left side we'll get log y, and on right side we'll get log 1 plus x whole raised to x. Now for further simplification, we are going to use third property, using which we can say this x will go in the multiplication of log. So here we get our simplest equation. Now if we differentiate our equation with respect to x, on left hand side we will get 1 upon y dy by dx, and on right hand side we have to apply multiplication rule. Let's say your x will be as it is, and we have to differentiate log 1 plus 1 by x, and for that we have to consider box around the 1 plus 1 by x. So differentiation of log box is simply 1 upon box into d by dx of your box. Within the box we have 1 plus 1 by x, so we just have to multiply differentiation of 1 plus 1 by x, 0 minus 1 upon x square, plus in second term your log 1 plus 1 by x will be as it is. We just have to differentiate your x, which will be 1. So in further simplification, we can say your dy by dx is equal to y into, we have to take LCM in first term. So your x will be as it is, your second term will become x upon x plus 1, and minus 1 upon x square will also remain as it is, plus log 1 plus 1 by x will also remain as it is. So this x square x will cancel out. We will get y into, let's rearrange the term in the bracket. Let's say your first term is log 1 plus 1 by x, and second term will be minus 1 upon x plus 1. And if we substitute the value of y, which is 1 plus 1 by x whole raised to x, we will get your simplest answer. which is given in option A. Ta-da! If for y is equal to cube root of 2x plus 1 cube, 4x plus 3 whole raised to 5 upon 7x minus 1 whole raised to 6, dy by dx is equal to y times a upon 2x plus 1, b upon 4x plus 3 and c upon 7x minus 1. Then we have to find a plus b plus c. Here we have our y, and this cube root can be rewritten as whole raised to 1 by 3. So we get our y is equal to our function. Now let's take log on both sides. So here we'll get log y is equal to log whole bracket raised to 1 by 3. Now let's simplify using third property. We can say this 1 by 3 will go within the multiplication of log. So we get 1 by 3 log whole bracket, which can be simplified using first and third property. So let's separate the terms. Log 2x plus 1 whole cube plus log 4x plus 3 whole raised to 5 minus log 7x minus 1 whole raised to 6. For further simplification, let's use third property in individual terms. These 3 will go in multiplication of log. Similarly, this 5 and 6 will also go in multiplication of log. So here we get the simplest form of log y. So we are ready to differentiate our equation with respect to x. So on left side we will get 1 upon y dy by dx. I have to worry about this 1 by 3. Differentiation of first term, which is 3 log 2x plus 1, will be 3 will as it is. Differentiation of log box will be 1 upon box into differentiation of box, or we can say coefficient of x, which is 2. Similarly, differentiation of second term will be 5 into 1 upon 4x plus 3 into 4 minus differentiation of last term will be 6 1 upon 7x minus 1 into 7. So here we can say your dy by dx is simply y by 3 within the bracket 6 upon 2x plus 1 plus 20 upon 4x plus 3 minus 42 upon 7x minus 1. Now, to compare the right hand side of dy by dx, which is given in the question, we have to multiply this 1 by 3 within the bracket. So this 3 will go with individual multiplication. So here we'll get 6 by 3, 20 by 3 and 42 by 3. By comparing both equation, we will get our A, B and C. So let's find out A plus B plus C. Your A is 6 by 3, or we can say 2, plus your B is 20 by 3, plus your C is minus 42 by 3, or we can say minus 14. So here we get minus 16 by 3, which is given in option A. Ta-da! If for y is equal to x raised to sin x, we have dy by dx is equal to y times f(x) plus cos x into log x. Then we have to find limit x tends to 1, fx. So first of all, let's get our function, which is equal to y, x raised to sin x. Now here we have second form of logarithmic differentiation. So let's take log both the side. So here we'll get log y is equal to log x raised to sin x. Or we can say, using third property, we can simplify this as sin x into log x. So we get the simplest form of log y. Or we can say we are ready to differentiate our equation with respect to x. So on left side we will get 1 upon y dy by dx, and on right hand side we have to apply multiplication rule. So let's say your sin x will be as it is. We have to differentiate log x, which is 1 by x, plus your log x will be as it is. We have to differentiate sin x, which is cos x. So here we get dy by dx is equal to y times sin x upon x plus log x into cos x. So if we compare with the right hand side of dy by dx, which is given in question, we will get our fx is equal to sin x by x. But we need to find out limit x tends to 1 fx. Actually, we have to find out limit x tends to 1 to sin x by x. Let's apply the limit and we will get sin 1 upon 1, or we can say sin 1 is your final answer, which is given in B. Ta-da! Here we have differentiation of log raised to log x is equal to fx into log x raised to log x. Then we have to find f of e. Basically, here we have y is equal to log x whole raised to log x, which is in the second form of logarithmic differentiation. So let's take log both the side to remove variable raised to variable. So we can say using third property we will get log x into log of log x. So we get the simplest form of log y, and we also ready to differentiate our equation with respect to x. So on left hand side we will get 1 upon y dy by dx, and on right hand side we have to apply multiplication rule. Let's say in first term log of log x will be as it is. We just have to differentiate log x, which is 1 by x, plus in second term log x will be as it is, and we have to differentiate log of log x, and for that we have to consider box around the inner log x. So here we have to differentiate log box, which is 1 upon box into d by dx of box. Within the box we have log x, so we just have to multiply differentiation of log x, which is 1 upon x. So finally here we get dy by dx is equal to y into log of log x upon x, plus this log x will cancel out, we will get 1 upon x. So if we substitute the value of y, which is log x raised to log x, then we can get bracket is our fx. So let's write down fx is equal to find f of e, we have to substitute x is equal to e. So here we'll get f of e is equal to log of log e upon e plus 1 upon e. Now value of log e is 1 and log 1 is 0. So finally we will get 1 upon e, which is given in option D. Ta-da! If for y is equal to sin x whole raised to x plus sin x raised to x, we have dy by dx is equal to sin x whole raised to x fx plus x cot x plus x raised to x cos x raised to x into gx. Then we have to find fx minus gx. Our y is in third form of logarithmic differentiation. So indirectly we have to find out individual differentiation. So let's try to find out the differentiation of first term, which is assumed as a u. Your u is sin x whole raised to x. Now, to differentiate u, you have to take log on both sides. So we get our log u, and let's apply third property. So we can say this x will go within the multiplication of log. So we get the simplest form of log u, which is x log sin x. So we are ready to differentiate our equation with respect to x. So on left hand side, we will get 1 upon u du by dx is equal to, we have to apply multiplication rule. So let's say your log sin x will be as it is, and differentiation of x will be 1, plus in second term your x will be as it is, we have to differentiate log sin x, and for that we have to consider box around the sign. So differentiation of log box will be 1 upon box into d by dx of box. Within the box we have sin x, so we just have to multiply differentiation of sin x, which is cos x. So here we get our du by dx as u into log of sin x plus x into cot x. Now let's move to our v, which is sin x raised to x. Let's differentiate our equation with respect to x. So here we'll get dv by dx is equal to differentiation of sin box. So differentiation of sin box is simply cos box into d by dx of box. Within the box we have x raised to x. Your cos x raised to x will be as it is. To find out differentiation of x raised to x, we can apply logarithmic differentiation, but we can remember the differentiation of x raised to x as a formula. So let's write down its differentiation, which is simply x raised to x into 1 plus log x. So we get our dv by dx. Now let's get back to our original question where y is equal to u plus v, and we need to find dy by dx, which will be equal to du by dx plus dv by dx. So our first term is your du by dx plus your second term is your dv by dx. Now let's compare with the given dy by dx. So we will get our fx as well as your gx. Now we have to find out fx minus gx. So your fx is simply log sin x minus your gx is simply 1 plus log x. Now to get the proper answer, we have to replace this one by log e. So using third property of log, we can say our fx minus gx will be log of sin x upon dx, which is given in option D. Ta-da! If for y is equal to 1 by x raised to cos x, we have dy by dx is equal to 1 by x raised to cos x, fx plus sin x log x, then we have to find x fx. First of all, let's write down y is equal to 1 by x raised to cos x, or we can say x raised to minus cos x. So we get our y is equal to function. Now let's take log both the side. So log y is equal to log x raised to minus cos x, or we can say our log y is simply minus cos x into log x. So we are ready to differentiate our equation with respect to x. So differentiation of log y will be 1 upon y dy by dx, and in right hand side we have to apply multiplication rule. Let's say cos x will be as it is. We have to differentiate log x, which is 1 upon x, plus your log x will be as it is. We have to differentiate minus cos x, which will be minus minus become plus sin x. So finally, we will get our dy by dx, which is equal to 5 times minus cos x upon x plus log x into sin x. Or if we substitute the value of y, which is 1 by x raised to cos x, we get the simplest form of dy by dx, which can be compared with the given question. So by comparing these two things, we will get our fx as a minus cos x by x. But please remember, we need to find out x into fx, which is equal to minus cos x, which is not given in A, B or C. So your right answer is D. None of this. Ta-da!